Hello grade 9s, this is Mr. Miller and welcome to lesson 7.3 on dividing polynomials by monomials. So at the top of the page here we have listed the various algebra tiles and you should be already familiar with these. But just in case you've forgotten, the positive ones are the ones that are shaded in and the negative ones are the ones that are white. The smallest square is a 1 tile. The longer shaded in tile would be a positive x tile because it's x by 1. The little bit shorter one is a y tile, and so the largest square one is a positive x squared, and here we have an xy tile that is x units wide and it's y units tall. So now going into question number 1 here, we want to figure out what polynomial division statement is being represented by these algebra tiles, and we want to determine that quotient. So let's see if we can figure this out. First of all, across here you can see that this is a width of 2x and you can see that we have a bunch of xy tiles here. We have 4 of them. And we have 2 other x tiles here. So basically it looks like the division that we're doing is 4xy plus 2x that is being divided by 2x. Now you could write this a different way. You could write this as brackets 4xy plus 2x. With the divided by symbol this way, 2x. But then you definitely want to use brackets to make it understood that you're, for instance, not just dividing by 2, but you're dividing by 2x. And it's the entire expression here that's being divided by 2x, not just the last term, for instance. So, and now to come up with the quotient, or basically we're using an area model here, and area is length times width to get the area, and now kind of working backwards and doing division, we're saying what is the length that when you multiply it by this width you get that area. So the length that would work here, because we know that this is x units in length just from there to there, you know that this has to be y units in length from there to there to get an xy tile. And so likewise you also have to have y here to multiply y by x to get that particular tile. And the same thing applies across the other column of tiles here. And finally, if you want to get an x tile down here, then you have to multiply x by 1. So it looks like the quotient is 2y plus 1. So that's using the area model. Of course, ultimately we do want to move away from this because it's very time consuming and space consuming to create these diagrams. We would like to be able to do them a lot faster, and so let's see if we can understand how we're coming up with this quotient from the algebraic expressions themselves without having to do a diagram. And so what you can do to figure out the first term is you take 4xy and you divide by 2x. So notice that 4 divided by 2 is 2, x divided by x is 1, so there is no more factor of x, but the factor of y is still there. So the factor of x divided out, but the factor of y remains. The second term is 1 because it's 2x divided by 2x, which gives you 1. So it's a plus 1 term. And now let's see if we can do the same kind of work to figure out part B. Now actually, if you can do this on your own, you might want to pause the video at this point and do it on your own, then press play when you're ready to check your answer. Okay, now if you're still stuck, I'm going to help you through this. So let's take a look at all the tiles we have here. We have a bunch of x squared tiles, and we have 6 of them. And then we have 1, 2, 3, 4, 5, 6 negative x tiles here. And what we're dividing by is 1, 2, 3x. And so the quotient that you'd get here is, since this is x, and we've got an x squared tile, the way that you get that is by multiplying x by x. Likewise across here, this is x by x to give us x squared, and likewise here we've got x by x to give us x squared. And so we also need to have x here. To multiply x by x means that we're going to get an x squared. So all that seems to make sense so far. Let's see what we should put here. Now initially you might be thinking 1, because 1 times x is x, but it's actually negative x that we're looking for, so this has to be negative 1. So negative 1 times x will give us that negative x tile. And likewise here, you're going to have a negative 1. So we've got 2x, and then we've got minus 2, and that's the quotient. Obviously, you know, we do want to move beyond this representing the quotient with algebra tiles, because like I said, it is space consuming and time consuming. So the way that you could get the quotient without having to do a diagram is 6x squared divided by 3x gives you 2x, because 6 divided by 3 is 2, x squared divided by x is x, and then negative 6x divided by 3x is negative 2, because negative 6 divided by 3 is negative 2, and x divided by x is 1. So that factor divides out and is, you wouldn't see that factor anymore, because of course negative 2 times 1 is just negative 2. Alright. Now, if you like, you can also draw in the tiles that should go here in the question mark. I like to leave the question mark in here because then that kind of differentiates this diagram from a multiplication diagram. And the question corresponds with where we would get our quotient for this division question. So let me just take a minute to put in the tiles that would go into this spot. So I'm just going to pause this for a minute and then be back with you in just a second. Okay, and we're back. So now I've put the tiles on here just to show you what they would look like if you put them into this arrangement of tiles. So it's 2y plus 1, this is the quotient here, and we've got 2x minus 2. So if you like, you can also put the tiles in there. In number 2, we want to use a model to divide each expression, and we want to determine the quotient. The first question is 9x squared minus 3x divided by negative 3x. Let's set up that framework. Okay, so here we have the framework. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 x squared tiles and minus 3x, and we're dividing by negative 3x, and so the quotient would go here. So since we have negative x across here, so since this is negative x, it has to be times negative x here in order to get that area of positive x squared. And again, with this one, because it's negative x, multiplying that by negative x will give us positive x squared. So all of these are negative x times negative x gives you negative x squared. So likewise, we're going to need another negative x here, and we're going to need another negative x here. So the only thing that remains is to figure out what goes right in the bottom spot here. So it's negative x times 1 that will give you negative x. So if we put all that together, it's 1, 2, 3, negative 3x, and then plus 1. And if you like, you can also put on the algebra tiles to represent that quotient. So I'll do that now. And now you can see that I've added in the quotient, which is negative 3x plus 1. Alright, next we've got 4x squared plus 6x, and we're dividing by 2x. If you think you know how to do that on your own, then by all means give it a shot. Pause the video, try it, and then come back when you're ready to check your answer. If not, then stay tuned. First thing I'm going to do is, just as I did here, I'm going to create that framework for this division question. Alright, so here's our framework. You can see that we've got 1, 2, 3, 4 x squared tiles, we've got 1, 2, 3, 4, 5, 6 x tiles, and we're dividing by 2x. So since across here we have x, we need to multiply by x in order to get x squared. And likewise here we need to do x times x gives us x squared, and so that also explains the other column, and it would be x times 1 that gives us x, and so same thing here, this is another 1, and finally down here this is a 1. So that means that the quotient is 2x plus 3. And now I'll just put in the tiles to show that quotient. Okay, so here is the quotient, 2x plus 3. Of course, we could have determined these quotients without using a model, except that we were asked specifically to use a model in this case, but we could have come up with this quotient just by doing 9x squared divided by negative 3x, and then also negative 3x divided by negative 3x. 9 divided by negative 3 is negative 3. X squared divided by x is x. So that takes care of the first term. Second term, negative 3 divided by negative 3 is positive 1, and x divided by x is 1. So there you go. The 4x squared divided by 2x would give you 2x, and the 6x divided by 2x would give you 3. So hopefully we can move beyond these diagrams now and just do it all symbolically. So the instructions on number 3 say just divide, and obviously there's not a lot of room to do diagrams in here, and I'd rather not because, as I've said, they're space and time consuming. So I'm going to get the first term here by doing 15x squared divided by 5x. So if you like, I can write that step down for this first one. 15x squared divided by 5x is how I get the first term, and minus 20x divided by 5x is how I get the second term. So 15 divided by 5 is 3, and x squared divided by x is x. 20 divided by 5 is 4, and the factor of x divides out. So that's what you're left with as your quotient. Now if you get how to do this, you may want to just go ahead and do B, C, D, E, and F on your own. Pause the video now and give that a shot. I'm not going to show all the work for all these. What I'm going to do is I'm going to pause the video, I'm going to fill in the rest, and then I'm going to start up again. So let's see if you can do it on your own first. Okay, so now I'm back, and you can check your answers. Part B is 4m plus 5n. Part C is 2k minus 1. Part D is negative 2 minus 3n. Part E, and hey, who doesn't like to party? 0.7d plus 0.9k minus 0.8. And part F is negative 3c squared plus 4c minus 2. So now let's move on to number 4. You are decorating the bulletin board in your classroom with pictures of your classmates. Each picture covers an area of 4x square centimeters. The area of the board is 4x squared plus 16x square centimeters. We want to write an expression to represent how many pictures are required to cover the board. So this is a division question. How many times can this go into that? So we want to take the 4x squared plus 16x and divide by 4x. And let's see what we get. Now I'm not going to do this with, I'm not going to model it using a diagram. I'm simply going to do the 4x squared divided by 4x, and then I'm going to do the 16x divided by 4x, and this will give me my answer. So 4x squared divided by 4x gives me x, and 16x divided by 4x gives me 4. And again, the process there is you're dividing the coefficients. 4 divided by 4 is 1, so this has a coefficient of 1. X squared divided by x is x. 16 divided by 4 is 4, and x divided by x is 1, so that factor divides out. So as a final statement here, you could say it would take x plus 4 pictures to cover the board. And there we go. That's the end of the lesson. Hope you understood that well, and we'll see you in class.